In this tutorial, we will use a Schneider PLC M221 CE60T with fast transistor outputs, an IGBT transistor IRFB4710, a 12-volt DC motor rated at 1 amp, some resistors to adapt the PLC output signal for the transistor, 1 flyback diode, and 2 power supplies, 12 volts and 24 volts. An Android smartphone, the app Modbus TCP IP Mobile, available for free on the Google Play Store. Here's the diagram of the complete project. How to control a 12-volt DC motor using a PWM signal generated by a Schneider PLC M221. The motor power stage is based on an IRFB4710 transistor controlled by the PWM signal and supplying the DC motor with 12 volts DC. The voltage divider ensures that the transistor gate receives the correct voltage. The gate resistor and the gate-to-source resistor provide additional protection because the PLC delivers 24 volts on output Q0.0, which is the PWM signal. A flyback diode is also added for protection. Let's speed up and build the motor power stage using the IRFB4710 transistor. Now, we will wire the power stage with the 12-volt DC motor. This type of DC motor is commonly found in printers. We add a heatsink to the IRFB4710 to help dissipate heat. However, in this project, there is no significant risk of overheating because the transistor is largely oversized for this small motor. Now we will wire and connect the whole system of this project. We connect the PLC, the router, and the switch because we are using Modbus TCP IP to change the PWM duty cycle from a smartphone. The smartphone communicates through the Modbus TCP IP mobile app. The router provides the network connection, and the switch distributes the Ethernet communication between the devices. The PLC is connected to the network and receives the commands that adjust the PWM output. The power supply provides 12 volts DC for the motor and the power stage. We are now going to move to the programming part of the PLC. Start Machine Expert from Schneider Electric. Go to the Configuration tab. On the right-hand side in the PLC type library, choose M221C6T. Drag and drop it onto the PLC image in the middle window. Click Yes to replace the default module. Go to the Programming tab. Insert a no contact to enable the PWM function and assign the address M10. Here, you can use any address you want. It does not matter. From the top library, insert a pulse generator. Connect its input to the on-contact M10. Go again to the Configuration tab and click on Pulse Generators on the left-hand side of the window. Now go to the middle window and click on the 3 dots to configure a new pulse generator. In the pop-up window, choose PWM as the type of pulse generator. Set the time base to 0.1 milliseconds and the preset to 1. By default, the output is Q0.0, as shown in the configuration window. The name of our generator is PWM0. Go back to the program and set the address of the pulse generator to CENT PWM0. To control the speed, we must modify the duty cycle. Therefore, add an operation expression block to set the preset parameter to be modified by a register address MW5. The parameter here is PWM0.P. Add a new operation expression block to modify the duty cycle with the register address MW10. The parameter here is PWM0.R. Go to the Commissioning tab to connect with the PLC. Select the IP address of your PLC. Normally, if the PLC is connected to the same network as your computer, it should appear in the Ethernet devices box. Select the PLC IP address and click Login. Upload the program to your PLC. Now we are going to test the project. We will use a smartphone to set the speed of the DC motor via Modbus TCP IP. The app we are going to use is Modbus TCP IP Mobile, available on the Google Play Store. I will leave a link in the description. Start the app and set the IP address of the PLC and leave the port at 502 by default. Click the Connect button to connect to the PLC. Go to the Read-Write Coil window to activate the pulse generator. Set the address to 10 and click the Write Coil button to activate coil number 10. Go to the Write Register tab to change the duty cycle by register address 10. Set the register address to 10, then try different values for the duty cycle. 0 means 0%, and 100 means 100%. For this application, there is a minimum value at which the motor cannot start. Here, it is around 8%. Sometimes even at 10%, the motor does not start. In industry, the minimum value is typically around 25%. Now we have reached the end of this project. We successfully controlled a 12-volt DC motor using a Schneider PLC M221, a PWM signal, and an IRFB4710 transistor power stage. We also implemented Modbus TCP IP communication to adjust the motor speed remotely using a smartphone. This project demonstrates how industrial PLC systems, power electronics, and network communication can be combined in a simple automation setup. Thank you for watching. If you enjoyed this video, don't forget to like, subscribe, and leave a comment.